changed by Felix, so that shows an example of what we mean by uncertainty in decision making. But I've tried as I was instructed, to kind of bring together what we've learned in this 1 month. So you will see some of your names pop up. So I apologize if you haven't thought that this will happen, but this is what I've done. So I'm going to choose a much simpler framework than Paula's model, and this is one that has been around, I think, probably for 20 years. Although the reference I found is only from 2009. The idea of capturing the socio-ecological, socio-environmental system as this network or cycle where you have institutions that make incentives or policies. These affect how people make decisions. I put landscape decisions here because that's the title of this workshop. I think it's decisions in landscapes, because the decision makers are usually small. Nobody really makes a decision at the landscape scale, but the collective decisions of many people through their actions and interventions are changing how the ecosystem looks like, the ecosystem structure, function, etc. And then through basically, nature, that leads us to a whole range of services, public goods. There's a few more names that you can use here. We tend to value some of those through where people are and what people prefer. Do they like to have food? Do they like to go out to recreate in nature? And that brings us to value or benefits or welfare. Again, you can choose a lot of different names here. And the learning or the information that comes out from the welfare of many people somehow, to me a bit magically, because I'm not a social scientist, through a process we might call social learning, affects the next round of policy. Sometimes this is quick in the case of adaptive management. More usually that takes a couple of years. So we can, for modeling purposes, break down this link. And in terms of trying to understand uncertainty in decision making, many of us want to know how a particular policy will affect the welfare of other people. So I'm going to use this framework, and I'm also going to be trying to break down what I'm talking about into these two realms. The real world, I have no idea where that is. But it is a real world, and obviously a moral world. Okay, and we've been talking a lot in this 1 month about modeling, so obviously that's a big component of it. There's a lot of uncertainty in the real world as well. So to start off with, this first link between institutions and decisions that people make. So there is a lot of uncertainties there. First, because the influence of institutions or policies outside of what we are looking at. One of the main things that farmers affect farmers is other farmers. And those other farmers might not be something that we thought of when we try to model the effect of policy. That's why diffusion of innovation is not instantaneous, for example. And then we need to think about different types of agents that are working at different scales and interacting with each other. So just to give an example of work I've done, thinking about policy design, this is a case of tradable permits for standing forest. You have buyers and sellers of those in the part of the new forest code in the Brazilian Amazon and Cerrado area. So we went out and we've done some social science. We've interviewed farmers who have a deficit or an excess of standing forest. These we call buyers and sellers. We asked them questions that it's a methodology called Q methodology. You're basically trying to find the different types of farmers, different viewpoints. And you end up with 3 different types of sellers and 3 different types of buyers. I will not get into the whole detail of that, but we also can quantify how likely they are to trade with each other. Now, the main result was that those that are untrustful and unwilling to participate were most likely to work with those who are distrustful about sellers and unwilling to participate. So that's obviously not a very good news for policy design of that new forest code. There's a more complexity here, but those that want long-term are most in agreement to those that want short term. So obviously they disagree on the length of contract, they agree on anything else. But getting that policy to actually work is probably unlikely. There's a lot of other things that we should reflect on in terms of this kind of interaction between policy and what people decide. And I think one of the things that we've talked a lot in the first workshop especially is this perhaps contrasting approaches by econometric or economic models and agent-based models, as well as equilibrium and dynamic models. So sorry for the reproduction. This is Callum Brown from KIT, and in his presentation on the first workshop, he talked a lot about ABMs. And if you look at ABMs, and it's a bit hard to read here, but they looked at how many ABMs had economic and individual, how many had diffusion or social networks, learning and adaptation, and institutional behavior. You see that these percentages are going down, and the number that have more than one of those is less than 20%. 3 of those is even lower. Here's another paper looking at 20 different models of agriculture in Europe, and you'll see that the percent that actually had a lot of those processes between farmers is quite small across the board. What's more, many of those ABMs are not validated or calibrated in the way that mathematicians will call probably proper uncertainty quantification. So most of them had no validation whatsoever, and then some had some comparison to observations, and you can see the rest. Very small percentages in terms of number of models. So this is agent-based models. On the other side of the fence, we have the economists. So I'll take Brett here as representing the economist. And Brett gave us several talks which were really nice about how do we try to solve everything with a function which is called the utility function. So that utility function is a magical function that takes everything that we care about and put it into a single number. Now that single number might not be pounds, but it is an index. And the argument of Brett was that even if we don't knowingly do that, every one of us, when we rank priorities, have some kind of a utility function in our heads, because otherwise we couldn't really decide on how to rank things. So utility put together a lot of different things, and it can depend on the person, it can depend on the time, it can depend on risk preferences, and in general, this is quite a flexible framework if you can implement it in practice. There are some examples that Brett gave where maybe there are irrationality, so prospect theory, where we care more about a small loss than a small gain, or the ideas of asymmetric dominance. I will leave that aside. This whole area led to the field of nudge theory, there's a lot of social scientists working on this. I think one of the more interesting discussions we had in that seminar was whether this is real or this is publication bias or only looking at short-term impact. I think it was a really nice discussion in this talk. So I'm going to preempt Peter's work for tomorrow, and on each one of those topics propose what I think is a technical challenge or a research question. So I think we need, and we all talked about this a few times, good ways of uncertainty quantification in agent-based models. And I think we need some kind of a toolbox that will be available, but also accessible, not just to mathematicians, but actually to agent-based modelers to do this kind of work. And I'm happy that the group of Exeter has already given us some GitHub to start playing with, and I'm hoping that more of that will come from this program. But in terms of research question, I think we need some data, ideally long-term, large national longitudinal survey of farmers' actions, norms, and intentions. I know Paula was saying that we need to use existing data, but there isn't such an existing data. So if the statisticians here can combine many different pieces of data and give us this, that will be great. But if we had any data, it would be good to know if people's non-rationality, like Brett was saying, actually has a big effect on what decisions were made in the past. So thinking about how actual actions are happening, So there may be some other factors like weather, climate change, natural disaster that are affecting things besides what we are thinking of. And then one of the things that in the modeling world we often do this is scenarios, and we have challenges in creating a set of scenarios that are representative, complete, real, legitimate, and doesn't impose any biases that we put on them. Often we have temporal lags in systems, especially when we talk about ecological systems. In many of the modeling exercises, this is ignored. Here is an example of using scenarios of work we've done in Spain. This is the inverse model that Jenny's already mentioned, which is a very simple set of models. This one is looking at annual water yield, and we've run this with different assumptions on what people want, environmental flows or not, different weather. So there are tools out there that allow you to explore a lot of parameters, if you are willing to sacrifice some of the complexities of the models. But often, ecosystems are represented in some way. So, for example, 1 by 1 kilometer pixels. And that also leads to its own problem. So, going back to Brett, this was then a Nevo tools that he presented to us. And if those of you who've been in that talk, we've talked about having either a grid or some kind of gauge catchments. And that has the problem of defining the grid. And maybe Lex will talk about it later, but in geography we have this classical problem of modifiable unit area problem. If you have the same data and you divide into units like this, you can have one result. If you define your grid in a different way, you have a different result. So how do we define a priori the best coverage? I think there was a very lively discussion on that in the talk that Brett gave. I think we still don't have a good solution. What is the best way of defining or separating space into some kind of a feeling of the area that is working best? And maybe here we need to get some ideas about the scaling behavior of ecosystems to think about this, or maybe something about how we call ecosystem services provisioning area. That's the kind of unit that is providing the service to particular beneficiaries. How does those scale or look differently across space, so we can define how a model should run. So most of us spend careers on this part. So this is where we actually think about uncertainty in models. And I would say, in giving that all of this has uncertainty, sometimes we try to think too much on creating the best and most complex model to represent what happened from a particular map to a particular service, and not think about simple models that can do just as well. I think that echoes what Jenny was just telling us. But it doesn't always work. So just one example again, with the inverse models that I was part of the development team of, we've looked at comparing the soil and water assessment tool, which is a kind of a gold standard, if you like, of water hydrology models, and the inverse model. And we've done that in 2 catchments, up here, down here. In one of them we had good correspondence and good comparison of the ranking of the different units, different sub-areas, and in one of them it was completely rubbish. So if you want to use a simple model to say which areas should I conserve or protect, which areas I shouldn't, you could use invest here, don't use invest here. Now, why? We have quite a range of possibilities. One of them is that this area is dominated by groundwater. That's already a technical detail which inverse model doesn't have. So obviously, probably you shouldn't work with a model that some of the essential processes are missing. So there's a long list here of uncertainties, and Chris gave this a few times. I think I'm again borrowing Michael Goldstein's list of different uncertainties either in the parameters, on the boundary conditions. The fact that we can't run the model too many times, we might need to approximate the model. The model itself might not represent reality, like the example I just gave. The data we use for calibration has uncertainty in it, and we are just using one model most of the time. I'm going to get to that in a second. we also, in the real world, are lacking knowledge. We don't know everything. We don't know all the processes. We don't understand all the backends, etc. And there's other issues, scale issues. I think there is a whole session on that. Or there was a very lively discussion on scale in this 1 month, model coupling and modular bias, which I'm getting to now. So Ian Holman gave us a nice presentation talking about the impression project and the integrated model that came out of it. So again, hard to see, but each of these is a model, and they are coupled to each other. I think there's also a session still about model coupling. A very interesting presentation by Ian was showing how the probability distribution of the outputs is actually not diverging as some of us have expected. So you put in uncertainty in one model that goes into the next model, but actually the probability distribution of the outcome of the full coupled model was actually becoming more and more narrow, which I personally find surprising. And then the other thing that Ian was talking about is the fact that each of those models have its own assumptions. So we have some uncertainty, we have some bias because the decisions we've made as modelers, and sometimes those assumptions will not be the same across models that we try to couple. I've had a lot of experience with that, trying to link remote sensing products, which some of us are not aware that many of them are models, to models where the assumptions made in building the Earth observation product were actually not the same as the model that was trying to use them as forcing data, input data, or calibration data. So a challenge, how to do this better, how to allow different modelers to interact with each other and compare different models. So maybe we need some kind of a virtual lab or a middleware. We had a nice talk about this, where we all try to combine our models and compare them against some common validation data. That would be a really nice thing to do. And I know Tom Oliver, that is also not working partly for DEFRA, has been pitching ideas along these lines. So I'm strongly supporting that idea from the strategic research program. But in terms of a research question, to me it was not clear why, or a priori, a coupled model system will have the error converge versus diverge. And if any of the mathematicians in the room is able to tell me that this is the general truth, I'll be very happy, because I was expecting the opposite. So now into the more social science or economics, going from services to welfare. Again, in the real world, we have many people and we need to somehow aggregate their welfare. And it's not a priori clear if you just should add up the welfare of different individuals, or you should think about different groups and also account for the more deprived people in the way you account for the total utility. And the preferences of individuals are unknown, changing, and complex in general. In terms of modeling, monetization is difficult for some services, and we've known that for quite a long time. But we also should appreciate that those methods that people use to put value, so willingness to pay, willingness to accept, hedonic valuation, so say looking at the value of houses near clear lakes versus eutrophied lakes, travel cost, they can all give different values. I think that was kind of brushed over in Ian Betzman's presentation. So here's one study we've done, again, using the same inverse models. And we've looked at a range of services, a range of beneficiaries to each of the service, a range of metric to quantify each of those, and then a range of parameter values to put numbers into each of those metrics. And what came out was that the effect of choosing the number of services had a bigger effect on the variance of the total economic value, and then how many benefits you actually included. And the parameter uncertainty, which is the one that most people actually use or look at, was sort of in par with the different numbers or the different metrics, and it was lower than all of those. The last thing about this has to do with biodiversity. We had a very lively discussion about biodiversity in this workshop, it's nutritiously difficult to put a dollar value on, but I think we even convinced Brett that we care about biodiversity. And that is an achievement. And therefore, there is a value to biodiversity, but we also know that we don't really have good mechanistic models for biodiversity, and those models we have are very different to the hydrological, agricultural, carbon models. So how do we square that circle? And I'm going to put Bill's idea here. One of the ideas that we've talked about is whether we can use some kind of a risk or vulnerability approach to capture the value of biodiversity. And we had a discussion about, Bill, that's your wording, probabilistic local extinction annihilation as a service. So I like that. I think we should still understand, if that actually holds water, and then in addition, the reason it's local is that, the chances of some species getting extinct across the whole UK because you removed a little bit of forest there is, well, 0. So there can be local extinctions, those can be affected by habitat, but at what is the right scale that you actually measure that? And is there any way of actually deriving that from economics and not just from what we want, which is the landscape scale? So I'm getting to the last piece of this circle, and that is how do we actually get that information from the real world back into the decision makers, which are part of the real world in a way. But there are a lot of barriers there, and I think Peter, you listed these barriers to using models in the opening workshop. Difficult to use, lack of transparency, lack of uncertainty, neglect of cultural values. We've also heard about the problems of requiring too much data or data that is not already collected. I would argue that we do need to collect more data because we are collecting a lot of data, but maybe not the right data to answer some of the questions we want to answer. In terms of how do we help decision makers use models, so I think we had a lot of discussion about formulating the models or co-designing the models with stakeholders. We often don't do that. We often, a lot of scientists still try to bring results to stakeholders, write a nice policy note, and think this will be the way of influencing policy. That doesn't really work. But I think there is still a question of how to do this better, how to build capacity within the decision makers so that they know what is the limitations of modeling in the first place. And we had some discussions on that this week. And then uncertainty needs to be communicated, quantified of course, but also communicated to decision makers. I wish I had some good slides there. I think there was some really interesting ideas, again coming from the impressions model, and Paula might have talked about it at some point. But I think this is really critical thing for us to think of. And then how do we balance the complexity of the model versus having a model which is simple enough to explain and also solve, perhaps. And I'm going to use Stefan's slide here, where we can think about two different types of models in general. One is what Stefan would call a strategic model. So these are simple models, generic, that are built to gain understanding. And they have the minimal, if you like, number of components that you need to make it to make the model work. And you can explore them across all conceivable scenarios because in many cases they are easy to maybe analytically solve or easy to get some kind of exploration of the whole parameter space, so you can describe what those models do. The tactical models is trying to actually make accurate predictions in specific situations, and those require a lot of data, enough complexity, uncertainty, stochasticity. Once you put all of those into the tactical models, you are left with the only option of simulating a few runs of those tactical models and seeing what the results you get. We've talked about those problems and trying to optimize models, etc. And I'm sure there will be some more talks about that later. So to me, the research question here is how we get any kind of general understanding. If a simple strategic model says that policy A is better than policy B, is better than policy C, is there any mathematical way to say, that if you put in, a model which is a bit more complicated, maybe stochastic version of the same model, maybe, with some quench disorder. I mean, the mathematicians can have a lot of fun defining what better model is or more complex model is. Would you get the same result, that policy A is better than policy B, better than policy C? That is what we care about. Now, and if we get the same thing, or we can understand how simple a model should be to get us there, we can do a lot to help the decision makers. And I think my last technical challenge about communication of uncertainty, I think we need some kind of a toolbox and some kind of a decision tree, if you like, or for modelers to say, how do we go about communicating uncertainty? I think there's a lot of best practices and projects that have been done on integrated models, on landscape decisions, but also across a whole range of other disciplines where modelers have tried to inform decisions to see, what are the best ways to communicate and quantify uncertainty for the use of models with policymakers. And I'm going to leave the list of research questions here, and thank you all.